You should start with a fresh sheet of loose leaf. I have my notes here. If I seem to get astray, remind me to look back at them. Usually I can do them without, but it's nice to have it sort of near the crest. Okay? Don't pick up the subfolder. Yeah. All right. So I'm going to show you 3 brand new special formulas for grade 12. They're going to simplify some of the problems that you're going to solve. They're going to make things a little easier, a few less steps. Not only that, they're going to make you able to solve more complicated problems. That's kind of the downside. You're looking for recycling?
Yes.
For accelerated motion. Okay, so I'm going to remind you there's 3 of them, and they get progressively harder. What word?
What's that title? Yeah.
Deriving the special equations for kinematics. Deriving is like creating, taking what we already know and sort of putting it all together. Deriving the special equations for kinematics. Do you want me to write it?
Yes.
All right.
That's very
Except for deriving.
The special equations See? Smart notebook can read my writing. You guys asked for it. The first one is commonly known as equation 1. Okay. Do you recall A equals delta V over delta T? That's not true. The acceleration is the change in velocity over the change in time. Now, do you also remember that delta V, the change in velocity, is Vf minus Vi? Right? Okay, so what we're going to do is we're going to smash those two together, combine them together. This delta V and that delta V are the same. So in other words, this little bit here is going to go in there. Okay? And so now, remember there was that whole bit about like where Vi is equal to 0, and you had to do this, but it was kind of lame because you know what the answer was already. This is going to sort of eliminate that. It's going to make things a little bit nicer. So you're going to have A equals Vf minus Vi all over. Now the delta T, I'm just going to slide this past you. You're not going to notice this, even though I'm mentioning it. I'm just going to write T. Because the delta T, I mean, it's really change in time, but most of the time, the initial time is 0, right? So really, delta T is just like, if it's over 2 seconds, it's 2 seconds. You don't have to go 2 minus 0, right? The only time you might have to be cautious is if there's multiple events and you have to find like the amount of time of some second interval, like 5 minus 2 or something, right? Very rare, I'm not going to worry about it so much, okay? So the delta T just kind of becomes T. Okay? And now I'm going to rearrange this for Vf. How do I get the T to the other side? Multiply. So over here on the left, I'm going to have A times T. On the right, I'm getting rid of it, right? So it disappears. And I end up with Vf minus Vi. And now I want the Vi going to the other side. And I want the Vf kind of on the left. Because people like the single one on the left, right? Okay? Can I do that all in one step?
What are you trying to find?
I'll tell you when we get there. I'll do it in 2 steps. We'll do the country version. How's that one, Brett?
That was good.
Yeah? Okay, so now I got the Vf there, but we're going to write that as, and I'll do it in red, Vf equals Vi plus At. And that you can put a box around, wrap it up, put it under the Christmas tree. Okay? Vf equals Vi plus At. It's really just the combination of those two. Okay? And if you stop and you think about it, it sort of makes sense. The final velocity is whatever the initial velocity was, plus how much speed you get by accelerating over a certain time period. Does that kind of make sense?
Yeah.
It does. It saves a few steps, doesn't it, right? And so the rule is, in my room, is if you've sat through this derivation, then you can now use that formula as you see fit. Grade 11s aren't allowed to use it.
What if I teach them?
No, you have to watch video. You're going to be a lawyer, right? Okay, so what I'm trying to tell you, your question was, what are you trying to find? I'm trying to come up with a simpler formula that involves those two things, right? Okay, so that's called equation number one. Now, I would suggest, I look around the room, I see a lot of people, some people use about a half a page, maybe a third of a page, quarter of a page. The next one you can probably fit on about 2/3 of a page. So you don't need to start a new page here. You might want to draw a line to separate it. I'm going to go to a new screen because I need more space. Guess what you call the second equation? Correct. Genius. This one's a little bit more of a challenge. Okay, I'm going to write, since displacement is, how about I just do this? Area under a VT graph. Yes, this is part of the derivation. It's our thinking, it's our thought process. Okay? When you're in faculty of science, in math, in science, calculus, physics, professors love doing this derivation stuff. Okay? That's why I do it, to sort of give you that sort of, introductory to it.
Thanks, Mr.
You're welcome. And I enjoy it too. Since displacement is area under a VT graph. So what I'm going to do is I'm going to draw you a VT graph. Okay? You should also draw it. And I'm going to use multiple colors. You don't necessarily need to. It just makes it a little easier for kids to understand if I do it in multiple colors. Okay, I'll just pause for a second and let you get caught up. So I've got myself a velocity time graph. So I've got time down here on the x, I've got velocity on the y, and I've got these 2 points right here. Okay? And the x coordinates there are ti and tf, right? The initial time and the final time. And the y coordinates are the initial velocity and the final velocity. So if I am looking at this area here, that shaded, red shaded area, that area, you already know, area under VT graph, that represents the displacement. Okay, so what we're going to do here, because Talia wants to know, we're going to come up with a formula that gives us displacement given values so that we don't have to do the graph. Okay? Remember how with displacement we had to go like average velocity? They were always like 4 or 5 steps long. We're going to simplify that. Okay. So, what shape is that? That red shaded shape. Geometric shape. Ooh, well done, Hassel. Not too many kids see that. Do you guys know what a trapezoid looks like? I always think of the trapezoid as what the elephant stands on at the circus. I realize that many of you haven't been. They don't do elephants at the circus anymore. Yes, Jeff is right. It's kind of like this, right? That is a trapezoid. Yeah, Pizza Hut. Somebody ever thought of that? Okay. So, if I rotate this, does that kind of look like that?
Yes.
Except that the bottom isn't at an angle. The bottom is just flat. And the technical definition for a trapezoid is, like a rectangle has 2 sets of parallel lines. A trapezoid has only 1 set. But that doesn't mean that one of those lines can't be perpendicular to the other one. So if I take that one and I purposely went in black there, and if I go like this, Ty is right. Oh, I didn't quite get it. It is, he called it a half a trapezoid. Technically, it still is a trapezoid. It just doesn't have that. Okay? It's still a trapezoid. Now, okay, Ty, I'm putting you on the spot. Area of a trapezoid. Know the formula? It is related to base times height.
You gotta figure out
You could break it down, but there is a formula. The area of a trapezoid is side 1 plus side 2 divided by 2. And when you add those two and divide by 2, you're really finding the average. When you add two things and divide by 2, you're finding the average. So we're going to find the average side length, and we're going to multiply by the height. Okay? Now, the side lengths here that I'm talking about are this one here, S1 and S2.
the ones that are perfect, or the ones that are parallel.
The ones that are parallel.
Don't change.
Yes, the ones that are parallel. And this here is the height. And I'll pause there while you're getting that down if you want. It's up to you. Now what I'm going to do is I'm going to ask you, what if this is sort of the generic trapezoid, side 1 and side 2 and H, if that's sort of generic, how does that relate to this trapezoid which has been rotated? Like in other words, S1 is equivalent to what over here in red? S1 is equivalent to what over here? Now remember, we took this thing here and we did what? We rotated. So it's really like this, right?
Yeah.
So the S1 is actually this one here. Now that's that distance, so that is actually the VI. Right? Right? This one here. Oh, don't drop. What do you... Right? That one there is the height, that at V1. Right? Rotate that back. Which makes the S2 equal to the VF. Well done. And the H, the difference in times. Oh man, we're cooking with gasoline here. Which is known as delta T. Okay? So now let's write this formula for area of a trapezoid, but instead of S1 and S2 and H's, we're going to write it as area equals, not S1, but VI plus VF over 2 times height, which is my delta T. Now, just stop and think for a second. Don't worry, it's all going to make sense at the end.
Promise.
Just, now, area here, but no, we're not done yet. I haven't boxed it up. The area is the displacement, right?
Mm-hmm.
Okay, just stop and think about a formula you already know. On the side, don't write this down. V bar equals D times D over T, right?
Yep.
Which means that D is equal to
V bar times T.
V bar times T. And what does average velocity, V bar, what's it equal to?
VI.
VI plus VF, because I'm going to Nice, eh? It's okay. Again, I'm reminding you, you don't need to be able to do this on your own. You just sit back and enjoy this process. And then I go, check. I haven't boxed yet. I'll tell you. You can, sure. Don't you just wait for the box. Is that what you said? Yeah. Okay. Now what I'm going to do is this. I am going to take VF here, and I'm going to replace it with... Yes, I am. Oh, yes, I am. I am going to take VI plus AT in red, and I'm going to plug it in for VF because it says it's equal to VF.
So could you copy that and then bring it over?
Sure, you want me to do that? I'll put this on the side if you want.
Okay,
And I'm going to write it in red. So I'm going to write D equals, oh, just relax, VI plus what? In red plus VI plus AT back to black, just like AC/DC, over 2, you like that one? Times t. And I'm going to let that delta t just slide out of the way and become t.
So it's gonna rock.
So what did I do? I replaced VF. I replaced this VF here, which I will circle in red. I replaced that VF there with this one here, right? With the VI plus AT.
When does that help you?
Let me simplify and box it. Hold on, you guys are just waiting. Can this be simplified?
VI squared.
Not VI squared.
That's
VI plus VI is a 2VI, right?
Yeah.
Okay. Now, how would you feel if I just said, like, instead of dividing by 2, could I multiply by a half? Come on.
It'd be the same.
It's the same thing, right? Well, it just makes things a little easier when I do it like this. So I'm going to throw in an intermediate step, and instead of divided by 2, I'm going to have 1/2, and I'm going to use the dot for times. And then this whole thing here,
Oh, so it just gives you the.
all I did was take the half, the divide by 2, and I kind of factored it out. Okay? I factored it out, and now I'm going to write that as VI plus VI is
VI.
2VI. 2VI plus AT, and then I'm going to multiply by that T out there. We're getting real close to done.
Only just like pre-cal.
Don't worry, it's all going to simplify down nice. Trust me. Trust in the force. Okay, now we're going to multiply. We're going to multiply. Can we do it all together in one step, you think? Can we go 1/2 times that times that?
No.
The answer is yes, of course. 1/2 times 2VI.
One.
It's just a single VI.
Yeah.
So D equals, right? A single VI, but I have to multiply that also by
T.
T. So it's going to be 1/2 times 2VI is VI times T, which is VIT.
V.
Yeah.
Well, you know what? The point is to be able to derive it. The point is not just here's the formula, go and use it.
That's
You have to go through the process. Okay, now I've taken care of this guy here. Now I got to take that AT times by 1/2 times by T. So I can't really do anything with the half, so it's just going to be 1/2 AT, that's a plus sign, 1/2
AT2.
AT squared. And that, my friends, is special equation number 2. D equals VIT plus 1/2 AT squared.
Yeah.
What that has done, remember those problems where you have to find the displacement, you had acceleration, you had to do like about 4 or 5 steps to get to D because you had that V bar, blah, 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 blah.
But that was
I combined all those 5 steps. Basically what I've done is I've taken those 5 steps and done the formula work for you, right? And now you can use the formula. Single step. No, I didn't say it.
That's all.
We're not teaching you the wrong things. We're building. We're just simplifying terms. Yeah? It's like when you start playing volleyball, right? You know, most of the time you start with this serve, right? Maybe you start with like bump, or they start like in grade 5, they start with the toss, right? They catch. Same thing. Don't do that. Swimming, do they start you with every stroke? No, they give you the kick more than they kick, right? Same concept. Thank you, Talia.
You're older.
You gotta cross the break ball.
Oh my god.
Okay, I hate to tell you this. That was the intermediate one.
Oh my god.
It's not even that.
This one will require a full page. This one will require a full page. Don't take it as a challenge. Of course, this is equation number 3. Here's the idea.
like physics anymore.
You don't have to do this. Once you've been through it, you can use the formula.
Okay.
We're going to take equation 1 and isolate t. We're going to take equation 1
Take F minus N.
and isolate t. That's pretty close.
Oh,
What?
Better be careful here. Take equation 1 and we're going to isolate t. When I say isolate t, I mean put t all by itself. So equation 1 was VF equals VI plus AT. If you're a big writer, a little smaller. Okay, how do I isolate t? I get t all by itself. So what has to happen? The VI has to go first or the A has to go first? The VI has to go first. So in other words, I'm going to have over here VF minus VI. And then to get rid of times by A, I've got to divide by A. Yes, I try to put the T with the little swoop at the bottom. Yeah,
and
it does.
makes it way less complicated. Especially on the last page when we have plus.
Yes. Okay, so now that I've done that, I'm going to insert into equation 2. Oh, yes.
Oh, yes, yes.
Now, what this does is it eliminates t. We're going to come up with a formula that allows us to work with kinematic situations that doesn't involve time. Okay?
That's crazy.
There it is right there. You're right. Why did Mr. Spigalski just put that on the board? Just wanted it in and just wrote that on the board? Magically?
You talked about
Oh, you told him what you were going to do, what we were going to do
it.
today?
So we were doing it, and he's like,
Well, that's where we're headed. But trust me, it's a long road.
that looks so simple.
Well, yeah. Well, I'm glad it's there because now you can see that it's worthwhile, right?
So if you want to take, we can start that.
But not so
And make me come over there. Okay, now what does equation 2 look like? Equation 2 looks like this. D equals VIT plus 1/2 AT squared. And yes, I'm going to take, I'm going to rewrite this in red just so that it's a little more visible. This is going to be VF minus VI all over A, right? So yeah, I'm going to take this and I'm going to plug it in there for T. Oh yes, Tyler. And it's got to be squared, and Karen's about to have, quick, someone go get the defibrillator. Eh? How do you know? You're probably right. The defibrillator, the automatic thing, if you're having a heart attack, you just put it on. Claire, yes, there's one in the bear pit, there's one by the gym, just in case you ever need one. You know, they're completely foolproof. You open it, and it literally tells you exactly what to do. And no, it's completely automatic. They're really cool.
And you just like put it on the person and
You do, and then you press the button. And if they don't need it, it won't work. Like it has a sensor. It won't give them a zap if they don't need it. Yeah.
because I was going to say
They are idiot-proof.
I can imagine if they did that. You'd probably still alive.
Okay, here we go. So, I'm going to go way over to the left because I know I need a lot of room. Okay, you guys. I'm sorry I brought up the defibrillators. So, D equals VI. Is it okay if I put it in red so you can see it?
Yes.
I'm going to replace this T with
That.
VF minus VI all over A plus 1/2 A, and then the T is going to be VF minus VI all over A, and it's going to be squared. You see what I mean about stretching your algebra skills? Don't worry, I will guide you. This is grade 12 physics. Yeah.
That's great.
That is why
Sean Ray confirmed for me that his first year physics is basically what we do in a unit, which is like 3 weeks to a month. That's 1 hour. People have done it. Hundreds of people have done it before you, and hundreds of people do it behind you. You can do it. Just tell me. I'll get you to that point, right? You'll be fine.
I trust you.
I'll get you there. Okay, here we go. So D equals. Now I have to take that VI and multiply it in, right? So VI times VF is simply VI VF. And we usually put the VI first. So that's going to be VI VF. And then the VI times the minus VI is going to be minus VI squared, right? And it's all over A. All I did was take VI and multiply it in by each one. Okay? It is, but it's on the bottom, right? So this is like VI over 1, and when you multiply across the tops and across the bottoms, right? Yes. Okay, now, what I'm going to do over here on the right is, I'm going to take that 1/2 times A, and I'm just going to slightly tweak it. I'm going to write it now as A over 2. Is that okay?
Yeah.
Okay, and then I'm going to do the red part where we do that squaring. Now, what do you remember about squaring?
You guys pull it out.
Do you remember how that works?
Everything in there is
Take like
by 2.
Like
the beginning and the end.
x plus y squared? How does that work?
Everything in there is
X,
squared.
X, X, Y,
Yeah.
Y, X, X.
It's like x plus y times FOIL. Yeah, I'm glad we shall teach that.
Actually, it is.
Oh, I know. Oh, no. So that's going to be what? X squared
Plus Y.
plus an xy
Y.
plus another xy, 2xy, y squared, right? Does that ring some bells? Okay. But now we're going to do it with VF minus VI squared. So that's going to be, I'll leave it in brackets for you. So the VF is going to be VF squared. Now the VF times the VI again is going to be, should I write it as VF VI or should I write it as VI VF? Yes, I should write it the same way as this, right? So we'll write that as, now that's going to be minus 2, right? So, because there's 2 of them, right? Just like 2xy up there. This is going to be like 2 VI VFs. And then the minus VI times the minus VI gives me plus VI squared. And it's all over. Now, here's the question. Does the A get squared, Karen?
No.
No. Yes. No,
No,
it's
2 gets squared.
I say yes. It's also
Inside the bracket. So that really means, doesn't it mean like VF minus VI over A times VF minus VI over A? And you multiply the tops, multiply the bottoms, so the answer is yes. So that's going to be A squared. Do you sense some simplifying coming?
Yeah, divide everything by
You
2.
should. You should. Okay, well, first of all, if you've got an A on this right-hand side, if you've got an A on the top and an A squared on the bottom, what can happen? That A can cancel, and one of these A's will cancel, right? So you're left with an A on the bottom. Now at this point, I hate this step because basically I have to rewrite the whole thing with just a little tiny difference. If you don't want to do this step, that's fine. I like to do it just to show kids. So this is going to be VI VF minus VI squared all over A. And this is going to be all that top bit there. VF squared minus 2VI VF plus VI squared. And it's all going to be over 2A. Every time I do that step, I see Professor Quackenbush in my head writing all that mumbo jumbo on this board. That sounds like it. Okay, let's pause for a second. How do you add fractions here? You don't remember? I heard someone say it. No, not flip, that's the divider multiplier. Common denominator. Common denominator, right? Okay, our denominators are A and 2A. Okay.
Just one A away.
Why didn't I multiply this 2, this one here, by what?
No, no, 2 under 8 over 2. Yeah.
Oh.
Multiply by all those parts.
Because when you multiply fractions, you multiply the numerators, right?
That's why it's 2A.
Yeah, that's why it's 2A. That's a good question. Okay, so what I have to do is, to get this to be a common denominator, I got to make this a 2A over here on the bottom. And if I make the bottom times by 2, I have to make the... Okay, so that's what I'm doing. I'm doing common denominator here. So D equals, so you got to multiply the top by a 2. It's all going to be over 2A. So that's going to be 2 VI VF minus 2 VI squared, right? Both of them by 2. Plus, and then all this over 2A, VF squared minus 2 VI VF plus a VI squared. Hear that? No. This is the only time you ever have to do this.
Why?
It's kind of like, to dive in the deep end, you got to swim the 5 laps or whatever. Once you do it once, you're good.
That's so stupid.
That isn't fair.
It's not fair.
You couldn't swim
I feel your pain, Ryan. I failed the scuba test at the short ones. I couldn't because I couldn't swim. I'm a lousy swimmer. I know. But the weird thing was, the next day we went snorkeling. They take you like 3 miles out into the ocean and say, yeah, go ahead. Like, really? You can't scuba, but you're just going to drop me in this little shark-infested ocean and say, go ahead and snorkel?
Go ahead.
How do you even start?
Go ahead.
Did you have to sign a waiver?
Probably.
No,
There you go.
I don't know.
Okay, so how do you add fractions now when the common denominator? You just add the tops, right? And here's where the cool part happens. Now we're adding the tops. Aren't you glad you paid attention to math?
Yes.
Okay, so you get to combine like terms, right? So I've got 2 VIVF, and I've got minus 2 VIVF. Is that not the best feeling?
Holy crap. So I didn't have to do any of that.
Minus 2 VI squared plus VI squared is going to be a minus VI squared, right?
Yes.
Nobody likes to start with the minus first.
Yeah.
So let's go here. Minus VI squared, right? And what's left over?
Yeah.
Oh, that got a whole lot simpler pretty quick, didn't it?
It's a long minus. Yeah.
I know, I love that part when I make that long line and everyone goes, same. Every year someone says that.
Yeah, I thought you were gonna write.
It's like that. It's like the, it's like the punchline right at the end. And now it's all just, what do they call that in English? We reach the climax and it's all like, what do they call that? Yeah. Just kind of wrap it up loose ends, right? It's like that little bit there after that last commercial, right? That's just that tidying up with the sitcom. Okay, so now I'm going to multiply both sides by 2a, and I'm going to get 2ad
Expose me.
equals vf squared minus vi squared. We want the vf all by itself, and so we're going to have vi squared plus 2ad is equal to vf squared, and nobody likes it like that, so that's going to become, and here we go, vf squared equals vi squared plus 2ad.
It was on the other side the whole time.
Mic drop.
I didn't use the whole page, you lied.
Did I?
Pretty close.
Pretty close though, right? Yeah.
I've got a whole quarter.
So we boxed that.
You box that one.
So is that A area or?
That A is acceleration. D is displacement. VI and VF are of course, right? You'll notice that there is no time. Okay? How did we get rid of time? Well, we did that when we made, let me go way back here, we took this t and we substituted in there and the t's disappeared, right? You've actually done that before, you just haven't realized it. Remember doing systems of equations? Where you got like the two equations you have to find what they match?
Yes.
And sometimes you can do it by adding, right? Or you can go like set 1 equal y and then substitute it in. It's the same step. The same thing, just more complicated. Okay. Okay?
Are the first two really relevant, or just used to get through?
No, you're going to use the first two. That's a good question. You're going to use the first two. This one's more or less like grade 11 style questions. I've just sort of made them a little bit simpler. This one here takes grade 11 questions and allows you to do it in one step instead of like 3. And this one here allows you to do questions that you couldn't do before because you always had to have time. Yeah. Questions? Sure. I hate to tell this to you, but there's a fourth equation. I sort of kind of lied. However, I'm not going to derive it. Okay? And it should be just a review for many of you, but I will tell you that you need to know this. A single line. Single line. Here's the formula. I'm just going to give it to you. Christmas present. X equals.
What are we writing down?
You're writing down x equals minus b plus or minus the square root of. Is it coming back to you?
Yeah.
Quadratic formula. Yes, well done. Usually I ask, what's that called underneath the root symbol? No one knows. It's called the discriminant.
What?
It's the discriminant. B squared minus 4ac is known as the discriminant. And what's the deal with that, Danielle? What's the rule about the discriminants? Remember? Well, like if it's negative, what does that mean?
It means it's not multiplied. It's not a function. No?
Not solvable, right? No solution.
The positive perfect square, there's two radicals.
Right.
Wait, positive non-perfect square.
How do you remember this?
We won't be dealing with irrationals too much because we deal in real life, but she's right. Let me just say it out loud because I've got to memorize some years. Minus b plus or minus the square root of b squared minus 4ac all over 2a. No, it's 2a.
It's
I'm just gonna trust them.
We're thinking of a different one, I think.
But I'm still.
over 2A.
There's,
That's deriving.
that's deriving it.
Oh my gosh. So do we just walk?
Yes, I'm not going to make, it doesn't say that I have to derive it for you. So I just give it to kids. Now the question is, I heard someone say, when are you going to need to do that? You use the quadratic when you're solving for a parabola, which is what kind of an equation? An x squared. Okay, so when you end up with an x squared, or what's going to happen to you guys is going to be a t squared times squared, then you have to be able to use that. Okay? Was that fun?
No.